Human factors in ergonomics.
Human factors and ergonomics is a multidisciplinary field incorporating contributions from psychology, engineering, biomechanics, mechanobiology, industrial design, physiology and anthropometry. In essence, it is the study of designing equipment and devices that fit the human body and its cognitive abilities. The two terms human factors and ergonomics are essentially synonymous. The International Ergonomics Association defines ergonomics or human factors as follows. HF&E is employed to fulfill the goals of occupational health and safety and productivity. It is relevant in the design of such things as safe furniture and easy-to-use interfaces to machines and equipment. Proper ergonomic design is necessary to prevent repetitive strain injuries and other musculoskeletal disorders, which can develop over time and can lead to long-term disability. Human factors and ergonomics is concerned with the fit between the user, equipment and their environments. It takes account of the user's capabilities and limitations in seeking to ensure that tasks, functions, information and the environment suit each user. To assess the fit between a person and the used technology, human factors specialists or ergonomists consider the job, activity, being done and the demands on the user. The equipment used, its size, shape, and how appropriate it is for the task, and the information used, how it is presented, accessed, and changed. Ergonomics draws on many disciplines in its study of humans and their environments, including anthropometry, biomechanics, mechanical engineering, industrial design, information design, kinesiology, physiology, cognitive psychology and industrial and organizational psychology.
Etymology.
The term ergonomics, from Greek ergon, meaning work, and pneumos, meaning natural laws, first entered the modern lexicon when Polish scientist Wojciech Jarzybowski used the word in his 1857 article Res ergonomii zyli nauki o pracy, opart na prodach potrotnitik z nauki przyrody, the outline of ergonomics. That is science of work, based on the truths taken from the natural science. The introduction of the term to the English lexicon is widely attributed to British psychologist Hywel Murrell, at the 1949 meeting at the UK's Admiralty, which led to the foundation of the Ergonomics Society. He used it to encompass the studies in which he had been engaged during and after World War II. The expression human factors is a North American term which has been adopted to emphasize the application of the same methods to non-work-related situations. A human factor is a physical or cognitive property of an individual or social behavior specific to humans that may influence the functioning of technological systems. The terms human factors and ergonomics are essentially synonymous.
Domains of specialization.
Ergonomics comprise three main fields of research: physical, cognitive and organizational ergonomics. There are many specializations within these broad categories. Specializations in the field of physical ergonomics may include visual ergonomics. Specializations within the field of cognitive ergonomics may include usability, human-computer interaction, and user experience engineering. Some specializations may cut across these domains. Environmental ergonomics is concerned with human interaction with the environment as characterized by climate, temperature, pressure, vibration, light. The emerging field of human factors in highway safety uses human factor principles to understand the actions and capabilities of road users, car and truck drivers, pedestrians, bicyclists, etc., and use this knowledge to design roads and streets to reduce traffic collisions. Driver error is listed as a contributing factor in 44% of fatal collisions in the United States, so a topic of particular interest is how road users gather and process information about the road and its environment, and how to assist them to make the appropriate decision. New terms are being generated all the time. For instance, user trial engineer may refer to a human factors professional who specializes in user trials. Although the names change, human factors professionals apply an understanding of human factors to the design of equipment, systems and working methods in order to improve comfort, health, safety, and productivity. According to the International Ergonomics Association, within the discipline of ergonomics there exist domains of specialization.
Physical ergonomics.
Physical ergonomics is concerned with human anatomy, and some of the anthropometric, physiological and biomechanical characteristics as they relate to physical activity. Physical ergonomic principles have been widely used in the design of both consumer and industrial products. Past examples include screwdriver handles made with serrations to improve finger grip, and use of soft thermoplastic elastomers to increase friction between the skin of the hand and the handle surface. Physical ergonomics is important in the medical field, particularly to those diagnosed with physiological ailments or disorders such as arthritis, both chronic and temporary, or carpal tunnel syndrome. Pressure that is insignificant or imperceptible to those unaffected by these disorders may be very painful, or render a device unusable, for those who are. Many ergonomically designed products are also used or recommended to treat or prevent such disorders, and to treat pressure-related chronic pain. One of the most prevalent types of work-related injuries are musculoskeletal disorders. Work-related musculoskeletal disorders, WRMDs, result in persistent pain, loss of functional capacity and work disability, but their initial diagnosis is difficult because they are mainly based on complaints of pain and other symptoms. Every year 1.8 million U.S. workers experience WRMDs and nearly 600,000 of the injuries are serious enough to cause workers to miss work. Certain jobs or work conditions cause a higher rate worker complaints of undue strain, localized fatigue, discomfort, or pain that does not go away after overnight rest. These types of jobs are often those involving activities such as repetitive and forceful exertions, frequent, heavy, or overhead lifts, awkward work positions, or use of vibrating equipment. The Occupational Safety and Health Administration, OSHA, has found substantial evidence that ergonomics programs can cut workers' compensation costs, increase productivity and decrease employee turnover. Therefore, it is important to gather data to identify jobs or work conditions that are most problematic, using sources such as injury and illness logs, medical records, and job analyses.
Cognitive ergonomics.
Cognitive ergonomics is concerned with mental processes, such as perception, memory, reasoning, and motor response, as they affect interactions among humans and other elements of a system. Relevant topics include mental workload, decision-making, skilled performance, human-computer interaction, human reliability, work stress and training, as these may relate to human system and human-computer interaction design.
Organizational ergonomics.
Organizational ergonomics is concerned with the optimization of socio-technical systems, including their organizational structures, policies, and processes. Relevant topics include communication, crew resource management, work design, work systems, design of working times, teamwork, participatory design, community ergonomics, cooperative work, new work programs, virtual organizations, telework, and quality management.
History of the field. In ancient societies,
the foundations of the science of ergonomics appear to have been laid within the context of the culture of ancient Greece. A good deal of evidence indicates that Greek civilization in the 5th century BC used ergonomic principles in the design of their tools, jobs, and workplaces. One outstanding example of this can be found in the description Hippocrates gave of how a surgeon's workplace should be designed and how the tools he uses should be arranged. The archaeological record also shows that the early Egyptian dynasties made tools and household equipment that illustrated ergonomic principles.
In industrial societies.
In the 19th century, Frederick Winslow Taylor pioneered the scientific management method, which proposed a way to find the optimum method of carrying out a given task. Taylor found that he could, for example, triple the amount of coal that workers were shoveling by incrementally reducing the size and weight of coal shovels until the fastest shoveling rate was reached. Frank and Lillian Gilbreth expanded Taylor's methods in the early 1900s to develop the time and motion study. They aimed to improve efficiency by eliminating unnecessary steps and actions. By applying this approach, the Gilbreths reduced the number of motions in bricklaying from 18 to 4.5, allowing bricklayers to increase their productivity from 120 to 350 bricks per hour. However, this approach was rejected by Russian researchers who focused on the well-being of the worker. At the first Conference on Scientific Organization of Labor, 1921, Vladimir Bekhterev and Vladimir Nikolaevich Myasishkov criticized Taylorism. Bekhterev argued that the ultimate ideal of the labor problem is not in it, but is in such organization of the labor process that would yield a maximum of efficiency coupled with a minimum of health hazards, absence of fatigue and a guarantee of the sound health and all-round personal development of the working people. Myasishkov rejected Frederick Taylor's proposal to turn man into a machine. Dull monotonous work was a temporary necessity until a corresponding machine can be developed. He also went on to suggest a new discipline of ergology to study work as an integral part of the reorganization of work. The concept was taken up by Myasishkov's mentor, Bekhterev, in his final report on the conference, merely changing the name to ergonology.
Aviation.
Prior to World War I, the focus of aviation psychology was on the aviator himself, but the war shifted the focus onto the aircraft, in particular, the design of controls and displays, the effects of altitude and environmental factors on the pilot. The war saw the emergence of aeromedical research and the need for testing and measurement methods. Studies on driver behavior started gaining momentum during this period, as Henry Ford started providing millions of Americans with automobiles. Another major development during this period was the performance of aeromedical research. By the end of World War I, 2 aeronautical labs were established, one at Brooks Air Force Base, Texas and the other at Wright-Patterson Air Force Base outside of Dayton, Ohio. Many tests were conducted to determine which characteristic differentiated the successful pilots from the unsuccessful ones. During the early 1930s, Edwin Link developed the first flight simulator. The trend continued and more sophisticated simulators and test equipment were developed. Another significant development was in the civilian sector, where the effects of illumination on worker productivity were examined. This led to the identification of the Hawthorne effect, which suggested that motivational factors could significantly influence human performance. World War II marked the development of new and complex machines and weaponry, and these made new demands on operators' cognition. It was no longer possible to adopt the Tayloristic principle of matching individuals to pre-existing jobs. Now the design of equipment had to take into account human limitations and take advantage of human capabilities. The decision-making, attention, situational awareness and hand-eye coordination of the machine's operator became key in the success or failure of a task. There was a lot of research conducted to determine the human capabilities and limitations that had to be accomplished. A lot of this research took off where the aeromedical research between the wars had left off. An example of this is the study done by Fitz and Jones, 1947, who studied the most effective configuration of control knobs to be used in aircraft cockpits. A lot of this research transcended into other equipment with the aim of making the controls and displays easier for the operators to use. The entry of the terms human factors and ergonomics into the modern lexicon date from this period. It was observed that fully functional aircraft flown by the best-trained pilots still crashed. In 1943, Alphonse Trapanis, a lieutenant in the U.S. Army, showed that this so-called pilot error could be greatly reduced when more logical and differentiable controls replaced confusing designs in airplane cockpits. After the war, the Army Air Force published 19 volumes summarizing what had been established from research during the war. In the decades since World War II, HF&E has continued to flourish and diversify. Work by Elias Porter and others within the RAND Corporation after WWII extended the conception of HF&E. As the thinking progressed, a new concept developed, that it was possible to view an organization such as an air defense, man-machine system as a single organism and that it was possible to study the behavior of such an organism. It was the climate for a breakthrough. In the initial 20 years after the World War II, most activities were done by the Founding Fathers Alphonse Trepannes, Paul Fitts, and Small.
During the Cold War.
The beginning of the Cold War led to a major expansion of defense-supported research laboratories. Also, many labs established during WWII started expanding. Most of the research following the war was military-sponsored. Large sums of money were granted to universities to conduct research. The scope of the research also broadened from small equipments to entire workstations and systems. Concurrently, a lot of opportunities started opening up in the civilian industry. The focus shifted from research to participation through advice to engineers in the design of equipment. After 1965, the period saw a maturation of the discipline. The field has expanded with the development of the computer and computer applications. The space age created new human factors issues such as weightlessness and extreme G-forces. Tolerance of the harsh environment of space and its effects on the mind and body were widely studied.
Information age.
The dawn of the information age has resulted in the related field of human-computer interaction, HCI. Likewise, the growing demand for and competition among consumer goods and electronics has resulted in more companies and industries including human factors in their product design. Using advanced technologies in human kinetics, body mapping, movement patterns and heat zones, companies are able to manufacture purpose-specific garments, including full-body suits, jerseys, shorts, shoes, and even underwear.
HF&E organizations.
Formed in 1946 in the UK, the oldest professional body for human factors specialists and ergonomists is the Institute of Ergonomics and Human Factors, formerly known as the Ergonomics Society. The Human Factors and Ergonomics Society, HFES, was founded in 1957. The Society's mission is to promote the discovery and exchange of knowledge concerning the characteristics of human beings that are applicable to the design of systems and devices of all kinds. The International Ergonomics Association, IEA, is a federation of ergonomics and human factors societies from around the world. The mission of the IEA is to elaborate and advance ergonomic science and practice, and to improve the quality of life by expanding its scope of application and contribution to society. As of September 2008, the International Ergonomics Association has 46 federated societies and 2 affiliated societies.
Related organizations.
The Institute of Occupational Medicine, IOM, was founded by the coal industry in 1969. From the outset the IOM employed ergonomic staff to apply ergonomics principles to the design of mining machinery and environments. To this day, the IOM continues ergonomics activities, especially in the fields of musculoskeletal disorders. Heat stress and the ergonomics of personal protective equipment, PPE. Like many in occupational ergonomics, the demands and requirements of an aging UK workforce are a growing concern and interest to IOM ergonomists. The International Society of Automotive Engineers, SAE, is a professional organisation for mobility engineering professionals in the aerospace, automotive, and commercial vehicle industries. The Society is a standards development organisation for the engineering of powered vehicles of all kinds, including cars, trucks, boats, aircraft, and others. The Society of Automotive Engineers has established a number of standards used in the automotive industry and elsewhere. It encourages the design of vehicles in accordance with established human factors principles. It is one of the most influential organizations with respect to ergonomics work in automotive design. This society regularly holds conferences which address topics spanning all aspects of human factors ergonomics.
Practitioners.
Human factors practitioners come from a variety of backgrounds, though predominantly they are psychologists, from the various subfields of industrial and organizational psychology, engineering psychology, cognitive psychology, perceptual psychology, applied psychology, and experimental psychology, and physiologists. Designers, industrial, interaction, and graphic. Anthropologists, technical communication scholars and computer scientists also contribute. Typically, an ergonomist will have an undergraduate degree in psychology, engineering, design or health sciences, and usually a master's degree or doctoral degree in a related discipline. Though some practitioners enter the field of human factors from other disciplines, both MS and PhD degrees in human factors engineering are available from several universities worldwide. The Human Factors Research Group, HFRG, at the University of Nottingham provides human factors courses at both MSc and PhD level, including a distance learning course in applied ergonomics. Other universities to offer postgraduate courses in human factors in the UK include Loughborough University, Cranfield University and the University of Oxford.
Methods.
Until recently, methods used to evaluate human factors and ergonomics ranged from simple questionnaires to more complex and expensive usability labs. Some of the more common HF&E methods are listed below. Ethnographic analysis, using methods derived from ethnography. This process focuses on observing the uses of technology in a practical environment. It is a qualitative and observational method that focuses on real-world experience and pressures, and the usage of technology or environments in the workplace. The process is best used early in the design process. Focus groups are another form of qualitative research in which one individual will facilitate discussion and elicit opinions about the technology or process under investigation. This can be on a one-to-one interview basis, or in a group session. Can be used to gain a large quantity of deep qualitative data, though due to the small sample size, can be subject to a higher degree of individual bias. Can be used at any point in the design process, as it is largely dependent on the exact questions to be pursued, and the structure of the group. Can be extremely costly. Iterative design, also known as prototyping, the iterative design process seeks to involve users at several stages of design, in order to correct problems as they emerge. As prototypes emerge from the design process, these are subjected to other forms of analysis as outlined in this article, and the results are then taken and incorporated into the new design. Trends amongst users are analyzed, and products redesigned. This can become a costly process, and needs to be done as soon as possible in the design process before designs become too concrete. Meta-analysis, a supplementary technique used to examine a wide body of already existing data or literature in order to derive trends or form hypotheses in order to aid design decisions. As part of a literature survey, a meta-analysis can be performed in order to discern a collective trend from individual variables. Subjects in tandem, two subjects are asked to work concurrently on a series of tasks while vocalizing their analytical observations. The technique is also known as co-discovery, as participants tend to feed off of each other's comments to generate a richer set of observations than is often possible with the participants separately. This is observed by the researcher, and can be used to discover usability difficulties. This process is usually recorded. Surveys and questionnaires, a commonly used technique outside of human factors as well. Surveys and questionnaires have an advantage in that they can be administered to a large group of people for relatively low cost, enabling the researcher to gain a large amount of data. The validity of the data obtained is, however, always in question, as the questions must be written and interpreted correctly, and are, by definition, subjective. Those who actually respond are in effect self-selecting as well, widening the gap between the sample and the population further. Task analysis, a process with roots in activity theory. Task analysis is a way of systematically describing human interaction with a system or process to understand how to match the demands of the system or process to human capabilities. The complexity of this process is generally proportional to the complexity of the task being analyzed, and so can vary in cost and time involvement. It is a qualitative and observational process. Best used early in the design process. Think Aloud Protocol, also known as Concurrent Verbal Protocol. This is the process of asking a user to execute a series of tasks or use technology, while continuously verbalizing their thoughts so that a researcher can gain insights as to the user's analytical process. can be useful for finding design flaws that do not affect task performance, but may have a negative cognitive effect on the user. Also useful for utilizing experts in order to better understand procedural knowledge of the task in question. Less expensive than focus groups, but tends to be more specific and subjective. User analysis. This process is based around designing for the attributes of the intended user or operator, establishing the characteristics that define them, creating a persona for the user. Best done at the outset of the design process, a user analysis will attempt to predict the most common users, and the characteristics that they would be assumed to have in common. This can be problematic if the design concept does not match the actual user, or if the identified are too vague to make clear design decisions from. This process is, however, usually quite inexpensive, and commonly used. Wizard of Oz. This is a comparatively uncommon technique but has seen some use in mobile devices. Based upon the Wizard of Oz experiment, this technique involves an operator who remotely controls the operation of a device in order to imitate the response of an actual computer program. It has the advantage of producing a highly changeable set of reactions, but can be quite costly and difficult to undertake. Methods analysis is the process of studying the tasks a worker completes using a step-by-step investigation. Each task is broken down into smaller steps until each motion the worker performs is described. Doing so enables you to see exactly where repetitive or straining tasks occur. Time studies determine the time required for a worker to complete each task. Time studies are often used to analyze cyclical jobs. They are considered event-based studies because time measurements are triggered by the occurrence of predetermined events. Work sampling is a method in which the job is sampled at random intervals to determine the proportion of total time spent on a particular task. It provides insight into how often workers are performing tasks which might cause strain on their bodies. Predetermined time systems are methods for analyzing the time spent by workers on a particular task. One of the most widely used predetermined time system is called methods time measurement, MTM. Other common work measurement systems include MOST and MOST. Industry-specific applications based on PTS are SOEC and GSD. Cognitive walkthrough. This method is a usability inspection method in which the evaluators can apply user perspective to task scenarios to identify design problems. As applied to macroergonomics, evaluators are able to analyze the usability of work system designs to identify how well a work system is organized and how well the workflow is integrated. Kanzu method. This is a method that transforms consumers' responses to new products into design specifications. As applied to macroergonomics, this method can translate employees' responses to changes to a work system into design specifications. High integration of technology, organization, and people, HITOP. This is a manual procedure done step by step to apply technological change to the workplace. It allows managers to be more aware of the human and organizational aspects of their technology plans, allowing them to efficiently integrate technology in these contexts. Top modeler. This model helps manufacturing companies identify the organizational changes needed when new technologies are being considered for their process. Computer-integrated manufacturing, organization, and people system design, CIMOP. This model allows for evaluating computer-integrated manufacturing, organization, and people system design based on knowledge of the system. Anthropotechnology. This method considers analysis and design modification of systems for the efficient transfer of technology from one culture to another. Systems Analysis Tool, SAT. This is a method to conduct systematic trade-off evaluations of work system intervention alternatives. Macroergonomic Analysis of Structure, MAS. This method analyzes the structure of work systems according to their compatibility with unique socio-technical aspects. Macroergonomic Analysis and Design, MED. This method assesses work system processes by using a 10-step process, virtual manufacturing and response surface methodology, VMRSM. This method uses computerized tools and statistical analysis for workstation design.
Weaknesses of HF&E methods.
Problems related to usability measures are employed include the fact that measures of learning and retention of how to use an interface are rarely employed during methods, and some studies treat measures of how users interact with interfaces as synonymous with quality in use, despite an unclear relation. Although field methods can be extremely useful because they are conducted in the user's natural environment, they have some major limitations to consider. The limitations include: usually take more time and resources than other methods, very high effort in planning, recruiting, and executing than other methods, much longer study periods and therefore requires much goodwill among the participants. Studies are longitudinal in nature, therefore, attrition can become